I'm here with Dr. Romano to do another video on circles.
Hi, I'm Dr. Romano. I'm Professor of Organic Chemistry here at Romano Scientific and the creator of the Orgo Man products and the author of the DAT Destroyer book. I'm here today with Professor Blois, who is going to do a problem with us on circles. All right, Professor.
Okay, here we go. We're going to do two problems on circles, actually. Let's read the first together. A circle of radius r, here's the picture, is circumscribed around a square. What is the ratio of the area of the circle to the area of the square? So we want the area of the circle over the area of the square. We're looking for that ratio. That's going to be the structure of our problem. Okay, so here we have we know that the area of the circle, that's pretty easy. It's going to be pi r squared. That's no problem. Now we want to find out the area of the square. Okay, how are we going to find the area of the square? Well, I know that the diagonal of the square is going to be a length that's 2r. Okay, let's call one of the sides of the square s. We don't know what it is, just call it s. Well, I know from the Pythagorean theorem that a squared plus b squared equals c squared, right? I'll write this down here. A squared plus b squared is equal to c squared. And if I look at that right triangle there, that square, that's going to be s squared plus s squared is 2r squared, or 2s squared is equal to 4r squared. Okay? I know that the area of the circle is s squared, right? I'll put that down there just symbolically. I can't use that for my answer because I introduced that variable to represent the side, but I know from this equation that s squared dividing both sides by 2 is equal to 2r squared. So now we can fill in the blanks. Pi r squared over 2r squared, and the r squares cancel out, and the ratio of the two areas is pi over 2. Who expected that? Well, there's our answer. Let's go to the next problem involving a circle. Find the radius of a circle inscribed within an equilateral triangle whose side length is 100. So here's my equilateral triangle, an equilateral triangle being a triangle in which all three sides are equal. So here's my inscribed circle, and given the nature of the symmetry of the figure, I'm going to drop this perpendicular, and I know that's going to cut this side in half. So this is going to be 50, and there is a triangle that I form from this dropping that perpendicular. So what I'm looking for is this side. This is we'll call that r. We're looking for the value of r. Find the radius of that inscribed circle. Well, what kind of a triangle do I have here? Let's just take a look. I know that each angle of an equilateral triangle is 60 degrees. And because of arguments of symmetry, I know this value, this line here that connects this vertex to the center of the circle, bisects that angle, and therefore I know I'm talking about an angle of 30 degrees, and this is the bottom angle is a perpendicular that I dropped, and this angle here is 60 degrees. So I'm looking at a 30, 60, 90 degree triangle. And I should know what the ratio of sides is for a 30, 60, 90 triangle. The side opposite 30 we'll call 1, the hypotenuse is 2, and the remaining side opposite the 60 degrees is the square root of 3. That's all I need to know. That's a necessary bit of information for me to solve this, because the lengths of this side of this reference triangle, 1, 2, square root of 3, is going to be proportional to the sides of my given triangle here, of the triangle I'm trying to find. So let's see, r is to 1. Okay, this is the opposite side. Opposite r is to 1 as 50 is to the square root of 3. And there's our answer right there. What's the radius of this circle? It's 50 divided by the square root of 3. And if you want to rationalize it, as sometimes is seen, we can call this 50 square root of 3 over 3. And there's our answer.
Okay, thank you very much, Professor Blois. Those were really solid questions.
Could be one.
Professor Blois will be back with you again to do some more electrifying math problems. All right, guys, good day to you, and hit those bugs. Bye-bye.